data set with a predefined number of classes and predefined statistical properties. The Knime Analytics platform has a few nodes to generate data. In this workflow, we generate first 3 simple Gaussian clusters along 2 coordinates. Using the data generator node, we generate 3 clusters here along 2 coordinates, 100 patterns with standard deviation 0.1, no noise, and starting from this random seed. If we want to visualize the data that we have generated, here they are. Those are the 3 clusters along the 2 dimensions. Each color represents 1 cluster. In this second workflow, we generate 5 clusters, each with a predefined probability along 3 dimensions. So here we generate an empty data table with just unique row IDs. Then this node is going to assign a cluster label to each one of the data rows with these probabilities. So each cluster has a 20% probability to be assigned one of the data rows. So this is the assignment performed according to that probability. Then we create the first dimension using the Gaussian distributed assignor. Here we assign data with mean 0 and standard deviation 150 along this dimension for cluster 0, mean minus 50 and standard deviation 100 for cluster 1 along this dimension, and so on. So for each cluster, we can define the mean and the standard deviation around which to generate the data for this dimension. For the second dimension, we do exactly the same. So we define the mean and the standard deviation along this dimension for each one of the clusters. And then the same for the third dimension. The node stressor can add some noise. So here you define along which coordinate you want to add the noise, and then you define the percentage to stress per each row and the percentage to stress per each column. The final results can be seen in the scatter matrix. So let's have a look across the 3 dimensions. So as you can see here, we have the 5 clusters, some of them with a lot of noise so that they completely overlap, and along some other dimensions, they are a bit more separated. And finally, the third workflow here is used to generate a time series. The time series is generated as a squared wave along 100 time points. So we use for that a time generator, which works like the data generator up here, but generates date time objects. So we generate 100 rows. We use this one as starting point, and we use this one as ending point. We can use both date and time for the starting and the ending point. We can also use the execution time as the starting point. Okay. So now, if we check the output, we can see that we have generated 100 dates between the 10th of December 2015 and the 10th of February 2016, our starting and ending points. Then the time series generator generates a time series for these 100 points in the shape of a sawtooth wave or a sine wave or a square wave or a triangular wave. We wanted a square wave, yeah? And those are the parameters for the square wave, the height, the length, and the mean. Okay. And then finally, we can visualize our square wave using the JavaScript line plot node. And here